Good afternoon. My apologies for starting late. We had a little bit of technical issue. Apologies, we are quite behind the schedule. This afternoon, we have Mr. Afeez Babatunde with us. He will be taking us on Microsoft Azure Data Fundamentals, which is the first steps you need in terms of essentials of data engineering. I will quickly introduce him. Mr. Babatunde is an MCT and a data analyst with over 6 years experience. He has his bachelor's degree in information technology and a diploma in data science. He's currently a senior data analyst. So this afternoon, you are in a capable hand. I'm going to bring him on board for him to please start. Mr. Babatunde, please go ahead. Thank you.
Yeah, okay. Sorry, can you confirm if you can hear my voice? Hello?
I'm sure the audience can hear you, sir.
Okay, fine. Good afternoon, everyone. Good evening, good morning, whatever you're watching from. Afeez Babatunde is the name, like I was introduced to everyone. That is quite somehow to me. Anytime people introduce me, I always feel somehow. So let me change my mic to this. Okay.
Perfect. So, in today's meetup, I think we are to look at the fundamental of data engineering. Not just for you. Maybe probably you have been hearing about different things like prerequisites for you to be a data engineer. So you might be thinking around how to get started. How can you even be part of this career? You have been hearing data analyst, data engineering, database administrator, business analyst, and even data scientist. So, how are you going to be part of this? Okay, I want to join a career path in data. So, you are trying to pick a specific, like, path that you want to follow you as your career. So, and today now you have decided, okay, let me even hear from them. What are they talking about? Let me even think if this is a career path I can dive into as an individual. So I will be sharing my screen. Kindly confirm if you can share my screen. Janet, if you can share my screen, if you can see my screen, kindly let me know.
I
Uh,
cannot see your screen. Are you sharing the screen?
yes, I want to share the screen now. Sorry, I'm sharing slide video. Okay, I'm sharing screen. Yeah. So share screen. Window, let me share a particular window here.
All right.
Okay, Chrome tab. Let me share my screen here. Now let me share windows. I want to share this document. Okay, perfect. So you can still see it, right?
No, I can still see your screen.
Like this.
Okay, here we are. Yes,
Okay,
we have your screen. Thank you.
okay, perfect. So let me project it in order to be more feasible. This how we project. Can you see the projection?
Perfect. Yes. Thank you.
Okay, so but I will try to, okay, let me do something here. Let me make it more better. Are you seeing my PowerPoint or you are seeing my projection?
I'm seeing your projection as a PowerPoint.
Okay, I think I should have it this
So
way
it's
then.
perfect, sir.
Okay, good. So today, the topic is all about Azure Data Fundamental. If you are not within Microsoft environment, probably you are within Google environment or Amazon environment, you might not be using Azure. You might be using another platform, either Amazon Web Service or you are using Google Cloud. So, let's first of all talk about Azure itself. What is Azure? We know that not everybody that knows what Azure means. Azure is a cloud computing owned by Microsoft. That's the first thing. So the part of it, which is for data, is what you are trying to understand the data aspect within what within Azure itself. How does it, like, how does it store data? How does it carry database? How can you maybe let me just say, how can you have your data within Azure, and you we kind of have a rest of mind, like, oh, my data is safe within this platform. So that's what we are going to be talking about today. Okay, without much information, without much intro, this is my profile. And anytime, any day you want to catch me on the go, you can always feel free to check me on what's it called, on Twitter. Yeah, you can check me on Twitter, or you can connect with me on LinkedIn. So Afeez Babatunde is the name. So yeah, so let's move forward. Okay, in today's agenda, we want to describe data itself. We want to identify service for relational database and for no relational database, and then identify service for data analytics. So this is what we are going to be talking about if time permits. If not, we can just pick some aspect and then make it understandable to every one of us. So if you are following me, just let me see a thumbs up, and we move from there. So then let me first of all, let's talk about data. What is data itself? You know, most of us, we be hearing data, 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 but people will still ask me sometimes. I always have like people asking me different funny question. I will just laugh and feel like, oh, what are you asking me, man? So when you talk about data, people always say, even especially those who are not in the field of this technology, when you talk about data analytics, they feel like, what are you doing in that data? What is it all about? Data always, you know, what is data itself? So not the data we are using for on our data bundle that we are using to browse on our phone. So because I've seen a situation where someone was asking me like, do you mean the data we are using on our phone is that what you are analyzing? I said, no, 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 you are getting it wrong. So data is all about information. When you talk about the concept of data, is just like what's it called? A collection of facts. Let's take it from there. What is data? Data is a collection of facts in such a way that this fact can be a number, it can be of description, and also it can be of observation that we use to record information. I don't know if you got it right. Let me come again. I said data is what? Is a collection of facts. You know what fact means? Maybe you want to extract something tangible about a particular event, about a particular object, about an individual. You want to get raw fact about them. You can take this raw fact in a number format, in a description format, and observation format. So all this is what you gather together and you call it information. For instance, now Janet is here. If I start ask Janet, oh, what's your name? My name is Janet. How old are you? Oh, I'm so super. Oh, where do you work? In just like within a few seconds, within 15 seconds, I'll be able to capture information about Janet. So I'll just be like, oh, now when I'm talking about the fact can be in form of number, you realize that I've gathered information which is number about Janet's age. Asking her about her age means, okay, I want to get a numeric information from her. So her age, you can be, okay, I'm 20 something years old. Okay, note it down. What is your name? My name is Janet. Janet is what? Is a description telling me that, oh, so person is Janet. If I now ask, okay, maybe and it's something happened and I said, okay, can you tell me about this, about social event, or you can, what do you observe about this thing? That's observation. So that's all about data. Now me gathering this data and turning it like collating it together, having it all this information together is what we call data. It might not be about someone's record, it might not be about someone's information, it might be about an event. It says occur in a particular store. It can be of maybe an incident that occur in a particular area. So that's what we call data, and that's all about information gathering. So you gathering information, maybe number, description, and observation. That's just what I can tell you that data is all about. So sometimes when you want to define something, just use something that is, is relatable. Make a sample. That's what I just did. And I'm trying to make it not the data you are using to subscribe on your phone, not the data we are here. People might be, what is this one saying? So it's always funny to me when I see people asking such question. But you are not older than I mean, what you don't know is not older than you, or what they how you normally call it. So that's just it. So the second thing here is what data can be of different type. You understand? So data can be classified into different formats. Like based on the format, you can categorize data. You can classify it. Like, so we have structured data, we have semi-structured data, and also we have unstructured data. So now trying to understand what structured data means and what is unstructured data. If you take, for instance, now, if you take your MS Word, someone is trying to give you a record, is trying to give you an information about something. So uh, you trying to capture information. Sometimes you just come up with a table. That's what you most familiar with. You come up with a table. You come up with what's it called? Column and row. You just feel like, oh, how many row do we have? How many column do we have that we want to capture? You might be thinking, okay, let's capture student ID, let's capture the first name, let's capture email address and the normal home address. So you can be thinking that way. Another way around it is semi-structured data. That's, if you have perfect information like in a tabular form, that's what you call structured data. We have column, we have row, everything is perfect. There's nothing, everything is structured in tabular form. That's how maybe when we get to concept of database, you understand better. So we have semi-structured data. So semi-structured data is all about what is it called? Uh, Store data in which multiple table can I do I let me just I'm trying to simplify it. Like, this semi-structured data is information that has some structure but which allows for some variation between entity instance, for instance. So, and the common way the people save this kind of information is in JSON format. JSON format in what? In probably those who deal with web application. JSON means JavaScript object notation. So semi-structured data always comes in that way in object format. And this sample of what you are seeing on my screen here. So the second here, what you are seeing here, they are saving information in a semi-structured format. Like when you talk about different this kind of database, what's it called, non-SQL database, like MongoDB as for example. So we have MongoDB. So we have this kind of information is saving as JSON format, which is what JavaScript object notation format. So that's semi-structured data. So this kind of information, they are not structured. But in a within object notation JSON, where you can save your data as an object, or it can be of a key value format. You have a key, you have value, you have key, you have value, just as the way we have name and Joe, we have last name to be John. So this is the key, this is the value. So then the last one is unstructured data. Not all data is structured or even semi-structured. So for instance, now are you telling me that a document file, yeah, a document or image or audio and video data always, or let me and also binary data file, they are not of specific structure, so they are what they are not unstructured data. So that reason why sometimes it's hard for someone to even save this kind of document, this kind of file, image, audio, video, documents, and so on like that. So, but you understand better. Just have it in mind, like, okay, data can be classified into what structure, semi-structure, and unstructured data. So let's move forward. And also, for instance, if you take a look at it from angle of a web development aspect, the way people structure their database is also matters. Depends on how they want to capture their information. Some people use NoSQL, while some people use relational database system to capture their information. It now depends. So now let's take it a little bit up. Like, okay, all this kind of information we have been talking about, all this kind of data, how can you store data? How is data stored? So so we have data which can be stored as what? Text, like delimiter text. So delimiter text in the sense that uh it's being separated with something, with maybe a delimiter, either comma, either full stop, either space, either tab. So delimiter text store your data in what format? In a text format. Like, sometimes you can get to see this kind of data in a text format, like in a plain notepad when you open it on your system. So you just see, like, okay, the first name here now is this, we have last name and we have email, and when you see the next line object is what? The same thing, Joe Jones, and the email, the same thing here. So this is the way it will save your document. And let's take it a little bit up. Can you see now? We have object notation now. This is how what I was saying, like JSON format, it save your document as what? Object notation. Can you see now? We have a customer. The first name is this, and the last name is this, and we have it as a different, like different objects. So extensible markup language, this is, for those who are familiar with web, you know what I'm saying. We have markup language, HTML itself, and then you can also have your documents being extract, or a file being extract, or a data from a database somewhere residing on a server. Maybe sometimes you want to extract information. That reason why maybe when you get to data analytics, is data analysis, you see something like, maybe when you want to get your data, it will ask you, do you want to get it in a text format or JSON format or XML format? Different format you can get your data. So, and we have a data in binary, such as blob. So when you get to uh, Azure services to store data, you see something like this. So because sometimes when you want to, especially maybe when you are within Power Platform, sometimes if you want to upload a document, so you have to convert it to a binary object first. When you convert it to a binary, this binary, when you the moment you upload your document, it turns it to binary, and this binary will be the one to upload to any of your any of your backend. Maybe you are saving to a SharePoint list, or whatever you are saving, SharePoint library. So anywhere you want to that data to that document to go, when it get back to SharePoint library, it will be of the format you uploaded. So binary objects is what is used to save large large document, and it will convert it to binary. When you convert it to binary, then the moment it gets to the back end, it converts it to normal document and optimized format. So ORC, packet, all this object recognition. So now another way, this is when you are saving a file. But when you come to database, so we have relational database in such a way that you try to avoid anomaly. That's what we call normalization. So when you talk about relational database, for instance, now you have customer, you have product, you have other table. Maybe you set up a table on your system, and you have your customer list, you have your product list, you have your line item list. Now event want to start occur. Now the event is what people place order. When people place order with date and the customer name, at least you know that, okay, someone ordered today, the order number is this, the date the person placed order, who was the customer that placed order. You will see it on this table here. So someone placed order on this table, and the product they are buying is here. That reason why you see something here, you see a line that, oh, product is relating to line item, what they are buying. We have order table, which is relating to customer, which customer is buying from us. This line item is also relating to this, telling me, oh, which customer is buying. So, and in some cases we have non-relational database, which is what key value, like what we said earlier. It can be of this format, it can be of this format, and it can be of this format. So that reason why we have the limiter test data. Also we have object notation, we have extensible markup language, binary, that's for large objects. And the last one we talk about, okay, other format is row based format, and then we have optimized that's ORC, which is optimized row columnar format, and we have packet, which is columnar data format created by I think Cloudera and Cheetah. So they're the ones that created that format, that, okay, you can also use this format to save your data. So another format is what graph format, which is this. So, but you might not be able to understand this as a beginner. I don't know who my audience are. So, but it's good to understand the basic concept of data. So it's good. Sorry. It's good to understand this better. So because when you get to the advanced level, maybe when you're talking about Azure Data Lake, Azure Blob, and other, maybe Azure, what's it called? Blob and some file system. So it won't be funny to you. It won't be look somehow strange to you, like, what's it all about? So it's good to understand the basic aspect of data, how data being stored on a server. Okay, transactional data workload. So data is being stored in a database that is optimized for online transaction, because sometimes too the way we save on our on premises is different to the way something save online. What I mean by on prem is what within your local server, but the way something data save online is different. So when you talk about transactional data workload, maybe from individual to database, from data, and the database carry other table. Data is stored in a database that is optimized for online transactional process, so that supports the application. A misread and write, like, read the product table to display the catalog, write to the order table to record a purchase. That's just the flow of what you are seeing on my screen here. That's what is happening. So for a user to place order, he or she must be able to read the product table, like the system should be able to read the product table from the database and display the catalog to the user, for instance, now when you're dealing with e-commerce website, you have to see what you are trying to order online before you can even try to place order. But the moment you place order, the system should be able to write back to the order table to record your purchase. So, and also data is also is stored using transaction. Transaction are what acid base. So the meaning of acid is what you have at the bottom line. Like, okay, atomicity means each transaction is treated as a single unit of work. I'm placing order here. You are placing order at the same time. Doesn't mean that we are doing the same transaction. So each transaction is treated as a single unit of work, which succeeded completed or failed completely. Consistency, transaction can only take the data in the database from one valid state to another. You should get that right. Transaction can only take the data in the database from one valid state to another. If one state is failed, that means this is it can move to the next. So isolation, concurrent transaction cannot interfere with one another. Even though we are doing the same thing at the same time, we are placing order of the same product at the same time, it doesn't mean that it will stop what we have on our uh, it will affect each other. And durability, when a transaction is succeeded, the data change and persisted in database. That's just it. So that's the meaning of acid. Like, transaction data is stored using transaction, and transaction is what acid base. So, and the meaning of acid means atomicity, consistency, isolation, and durability. So, yeah. So let's talk about analytical data workload. You know, from database. For instance, now let's check from the number one. Data file may be stored in a central data lake for analysis. You might not understand what data lake is all about now, but I will explain it when we get there, unless if our time is not permit, like maybe when we exceeded our time. So maybe we can just share the file with everyone. If you need the material, you can just let us know. So data file may be stored in a central data lake for analysis. An extract, transformation, and load process copy this data from where? From an online transactional process database into what? Data warehouse. So as you can see now, if you perform ETL process, it does what? It copies data from file and online transaction process. Don't forget our what is it called? OLTP here, which we call online transaction processing operation database into a data warehouse. So, and do data warehouse can be of any type, but when we get there, you know what data warehouse is all about. Data is optimized for read activities. So from there, data in the data warehouse may be aggregated and loaded into an online analytical process. So check this now. The third stage. So when you take your data from data warehouse, it can be of aggregate, and you are taking it to what? Online analytical processing, or cube. So now from there, analyst, the data in the data lake, data warehouse, and analytical model can be queried from to produce a report and dashboard. So this is where at the end point, maybe as a data analyst, you connect to this data. Data engineer, they are done with their work, and they've kind of trying to as a data analyst, you trying to fetch your data using either your Power BI, your Microsoft Excel, and just to query the data, and then you do what? You trying to pick it from there and then try to start watching it, like watching your report in a real time. So that's what it's all about. So let's talk about relational data, the relational table. You've seen an image here talking about relational database. But let's talk about the table itself. When we have a database, since we said we can also store our data in database, what is database itself? So when you're talking about database, a database is used to define a central system in which data can be stored and queried. So uh, it usually means that a dedicated system for managing data. You understand? So you trying to use a dedicated system to manage your data. Now, when you talk about relational database now, it's commonly used to store and query structured data. The data is stored in table that represent what's it called, entity. You know, for instance, now within my database, I have what's it called? If I'm having uh a customer data, I am having product, I'm having order, having line of item. This represent different entity. So when you say data is stored in the table, and table consists of what? Rows and column. Like what we have here, it has rows and it has column. All rows have the same column. Not that maybe for instance now row 1 is having 20 column and row 2 is having 10 column. No. And each column is assigned a data type. For instance, now this ID can be of integer, can be of number. That's when database data type comes in. You have to define it from when you are creating your table within your database. Like, okay, this ID should be in number or should be in alphanumeric, or that's in text format. Why this first name should be in text, or we call it character as a data engineer, maybe when you want to define it at the back end. So middle name should be in text format, same thing as character. So when you're maybe sometimes some of us might be familiar with what's called SQL database or some other relational database like that. So if you're having all this, so you should know how to define your table in database. So another thing that you need to understand, like each uh, table, you need to avoid um, uh, what's it called? You have to normalize all your table. So when normalization comes in is when you need to break your tables into what different entity, because since each table has row and column, you assign different data type. So that's the reason why they are calling it the relational database. Relational table here now means this ID for a customer is can be used here as what? Customer ID. This product name can always connect to this to form a relationship. This is the primary key here and it's acting as a foreign key here. This is unique here, but it might not be unique on this table. Customer number ID, which is ID 1 and 2 here, must be unique here. We can't have same customer having the same ID. So we have this, and this is at this point now as a foreign key. It can be of many. As a data analyst, this is where we have different uh, type of relationship between tables. We talk about many to many, one to many, and so on like that. So that's for data analyst. So this a relational table. They are relating to each other. Okay. Normalization. Let's come to normalization here. Don't forget, I've been mentioning normalization. Normalization. What is normalization? Separate each entity in its own table. Imagine you're having your order, you're having order date, you're having customer as a flat table. You're having product, you're having quantity on a single table. This is not is abnormal. I think there's a word we normally use for it. I can't recall. So I don't know if you are getting what I'm saying. If you are following us, let us know. Let's see your hand. So or if you have any comment, if you have any question, you can just let's have your question, or you are not getting it right, you're not getting what I'm saying. Actually, you can actually uh, let us know. So when you separate each entity into its own table, you are trying to normalize table now. When you are having a flat table, we call it flat table. So now you just think, no, what if I want to make this a relational table? So you separate each discrete attribute into its own column. Uniquely identify each entity instance using a primary key. Don't forget that. Can you see? This table you are seeing at the top is what has been breaking. This sales data is what can be, we can break it and we can normalize it into this anomaly of database. That was what I was looking for. So anomaly of database is what? Normalization. So now you are trying to use a foreign key column to link a related entity. A foreign key on this table can be used to relate back to this, which is the main table. Now we have what we call, don't forget, in data analytics we have what we call uh star schema when it comes to data modeling. When you want to model your data, you talk about relationship. And when you talk about relationship, you know how to connect your table together from dimension table to fact table. So at this point now, my other table can be my fact table, and line item is also my fact table. So other like customer and product, they are just a dimension table telling us more details about what we have on the other table and line item. You understand? So this really helps a lot in reducing data redundant on the database and so many stuffs on database. Imagine we keep repeating all this, it will actually consume a lot of space in our database. So that's the essence of normalization. So now, I don't know, can we continue, Janet? Are we good?
Yes, let's continue for the next 10 minutes, please. Then we go to question session, please. Is that okay?
All right, great. Here, I just sorry for that. I just say let me ask. So okay, now we've talked about data. We've talked about how data is being represented, like format of data. Like we classified into structured, semi-structured, and unstructured data. We've talked about how to store our data in database. Different formats you can use to store our data. We've talked about it. Now, let's talk about how. Imagine you are having your data within your database. How do you get it? Maybe you want to, I don't know, let me call it query this time around. You want to fetch something. You are the one that saves something inside this database. You are the one that saves something inside this table, or you even the one that save your document as with delimiter text format. So how do you query all this data, especially when they are within RDB? So There's what we call structured query language, which is SQL. Like, sometimes we call it SQL. So SQL server, SQL is what structured query language. So we use structured query, is a standard language for uh use with a relational database. When you talk about, we've been talking about relational database. Okay, I want to query a RDB system. So while trying to query RDB, I'm trying to use a query. The standard is you use query language. So which type of query language you are using, I don't know. So it's of different fashion. We have MySQL, we have SQL, Transact SQL, we have PostgreSQL, we have NoSQL is there too. Like, we have Oracle SQL is there, SQLi, and so many different fashion. So now you trying to use either of these. I don't know how you use it, but I believe within Microsoft use Transact SQL mostly. I don't, yes, which I'm very sure of that. So Microsoft use Transact SQL, which is applicable when you are using my SQL Server. So if you have SQL Server Studio, you try to use it. You just make sure that the syntax you'll be using there is all about Transact SQL. So yeah, so the standard are maintained by this ANSI and ISO. That's their own issue. So they are the ones trying to maintain all this query language, to know syntax and everything, to make everything standard for everyone to use. So, and we said our what most RDBMS system support proprietary extension of standard SQL. You understand? So most database management system you might be thinking of as of today always support SQL. Now it now depend on the extension of the standard SQL. You understand? That reason why we have different fashion. So, and in SQL is what divided into three. So when you talk about SQL, you are trying to query your database, you are trying to, so you can use what we call data definition language. We have data control language. We are trying based on the syntax. I mean, based on syntax, you can use data control language and you can use data manipulation language. So because I normally tell people like, see, forget, there's 5 steps you need to know when you're talking about database. So there's something we call CRUD system in software development, so or even in data engineering or even in data query system. So you should know how to define a data. That's how to create, how to retrieve, how to update, and how to delete. That's 5 things. And the other one is what? Manipulation. That's maybe computational aspect of it. So if you know all these 5, you are good with database. That's the essence of what we have under here when we have data definition language. Data definition is all about you creating, altering, and dropping or rename something within your database. So you are trying to create a table, you are trying to alter a table. Alter means change. You are trying to drop, it means delete. So when you create, when you alter, you drop, or you rename, you are trying to do what? Data definition. When you talk about data control language, maybe you are trying to grant, deny, or revoke something within your table. So I'm granting you permission to do this on my table. Sure, that's good. To which user? That's just it. Or you are trying to refat. Don't forget, imagine you are trying to use ATM machine and it wasn't work successfully, and you trying to when you try to complain, there's something at the back end which is called data control, which tell us whether the transaction was successful or it was revoked. So just as an instance, this syntax telling me that okay, at the point of data definition, I have created a table product ID, integer, primary key, make it primary key for me, name. So this is just a SQL syntax. While we have data control here, like grant, select, or insert input update on product to a particular user. So, and the last one is data manipulation language. So, I'm trying to data manipulation, maybe I'm trying to fetch information. This is where retrieving is coming in. I'm trying to retrieve information from my database. I'm trying to update, I'm trying to delete, or I'm trying to select. So you might be thinking, here now I have delete, here I have drop. Delete is applicable to a table, like to a row within our table. While drop means you are dropping a complete table. You are deleting a complete table. So you have select name price from product where price is greater than 2.5, and order this by what price for me, and the result will come up in this format. So this is a simple explanation of structure language, which is all RDBMS systems support based on their extension. If you're a developer, if you're a data engineer, you are trying to, or even a data analyst, you are trying to do what? You are trying to learn how to communicate with a database system. So you should learn any extension of this SQL based on what? Based on your environment. Probably you are within an open source environment now. You don't want to use Transact SQL. You can go for Postgre, or you can go for MySQL extension. So, but for instance, now you are within Microsoft, you know that okay, the extension Microsoft uses is what? TSQL, which is Transact SQL. You can go for it and learn all the syntax needed to do all the DDL, DCL, and DML uh, in your database. So, hope we got it. Thank you for this. And other common database objects are this. So we can have something like this store procedure. We can have index. So this explain better about uh some other things you can see within your database. So just depends on how you familiarize yourself with the SQL statement. And so at this point I still have some some uh let me say some part of my slide, but I know that the time given we might not be able to complete everything. We want to talk about Azure Data Lake, Azure uh MariaDB, Postgre. We want to talk about Azure Data Factory, Azure Data Brick, Azure Data Explorer, and some other things under the fundamental of data engineering within Microsoft environment. So if you can see my screen now, you see realize that maybe I tried to skip it, and I still have a lot of uh, things on this slide, so which you can still explore if you need it. So I just want us to stop it here in case you have
All
any
right.
question, and we are ready to take it up from there.
Okay. Please, if you have any question, can you please drop it in the comment section? While you are dropping your comment, your questions rather, I would like to say thank you to Mr. Babatunde. This was a good session. For me, it was more of throwing more light on data definition, data control, data manipulation as well, which was great. For the continuation of this session for next week, it will be on Azure Data Lake. The link is in the comment section for you to please register at the same time next week between 3 to 4, please. And please also kindly fill the feedback form as well. So please, can you please drop your comment, please, in your questions in the comment section, please. Oh, thank you, Adepeju, for that. You can. There's no problem if you join late. You can actually go back to view the video. Is there on YouTube channel, so you can view later on at your own convenient time, please. All right. If there's no question again, within the next 2 minutes, if there's no question, we will close the session and I will say, see you next week. And thank you for joining us.
Yeah, so that's just it. And if you have any question, or you want to connect, or you want to get in touch with the organizers, or you even want to chat me personally, you can just post me on Twitter at the Web Guru. This is my what's it called? My Andrew. Yeah, that's what they call it. So
Yes,
that's
and
my username actually. So this is my username, and you can always chat me up there, and then I will link you up with Janet, or even Janet. You can drop your, maybe your what's it called, your social media handle. If they can chat you up there, they might have interest in joining the community. Someone might have interest in learning more about data engineering itself, and even want to be part of this community. So the community has been helpful for a lot of us, and when you have questions, people tend to attend to you, even on WhatsApp group, not to talk of the global community environment. So if you have interest, you want to join us, you want to do more for your community, you want people to, you want to make yourself like, you can do something like this, you want to do community service, and you can join along with us, and you are always welcome. So thank you guys, and see you next time. Great. And
thank
bye
you
for
all
now.
for coming and see you next week. Thank
All
you.
right. Yeah.
Bye, everyone. Bye.
Yeah. Bye.